done this, and I kind of wrote this up on the board here a second ago. F of x is 2x. What do you do? In which equation? Ladies. Right. This is your basic function operations. F of x, g of x. This is called, for lack of better terms, direct substitution. You guys have seen this before. This is something that you will see on ACTs. It's so commonly used. They use a lot of this function notation for a lot of stuff. What this is basically telling you to do is you take the f equation and you substitute 6 in for x. So you get 2 times 6, otherwise known as 12. Okay. The twist upon it that we're going to do today is that we're going to do what's called composite functions. We're going to mix them together. You're going to do this. What is f of g of x? What is f of g of x?
X, would that be x minus 3?
Well, here's what happens. When you work with something like this as a composite function, you look at it as your innermost parenthesis working your way out. Well, in this case, the innermost stuff, you're looking at g of x. What is g of x? X minus 3. So then what is f of x minus 3? Very good. So you get, it's at the 2x. You're taking that value and you substitute in for x. So you wind up with 2 times x minus 3. They did 2 different problems here. The original equation is this and this. These are 2 different problems. Problem number 1, problem number 2. It is nothing more than substituting back and forth. Okay. What's going to happen, though, it's not going to be just simple ones with these linears. It's going to be all the funky exponent rules and things like that. You have to just watch your rules. Okay. It's how these things are going to mix up. Don't write all this out. All I'm showing you here is that what they're doing is they're creating.
Wait. Then why isn't the x from the 2x put in front of the x minus 3?
Why is the x from the 2x?
Because f of x is 2x.
What I'm doing here is I'm taking whatever g of x is, and I substitute that in to the x. Okay? It's like whatever is in that inside parenthesis part, you're just putting it in. It literally is direct substitution. If it said potato, you'd have 2 times potato. If it was g of shoe.
Twice as many potatoes, so I can share.
Exactly. So it works the same way with stuff like this. If we have our 2 functions are if f of x is 2x to the half and g of x is negative 6x to the half. And I want to figure out what is f of x plus g of x, or what is f of x minus g of x. All I am doing is literally writing down the equations and combining like terms. So this example here, f of x is 2x to the half. G of x is negative 6x to the half. What do you get? Negative 4x to the half. All you're doing is combining like terms. Does that make sense? Works the same with subtraction. What are you going to screw up when you have subtraction of a negative, though?
You're going to have to do the W.
Yeah. You get 8x to the half. Not that bad, is it? Adding, subtracting, what's that? And then, but wait. Like I said, the weird stuff is going to be multiplied through. You're just going to have to watch your rules, your power rules. That's about it. Okay. What this stuff is going to allow us to be able to do as we get into 6.4 is when we're working with inverse functions, we'll be able to write them out a little bit cleaner. It makes it a little bit easier to see how these things work. Same thing, multiplying and dividing. If my two functions are 3x and f of x is 3x, g of x is x to the fourth. Yeah. If I wanted to multiply them out, it's nothing more than 3x times x to the fourth. What do you get?
3x to the 5 fourth.
Using your exponent rules again, same base, different exponents. You're multiplying, you add the exponents together. The 3x, the x value has an exponent of 1. It's just not written. You just add a fourth to it and you get 5 fourths. So your final answer, when you multiply them out, would be 3x to 5 fourths. When you're dividing them, remember you got to play that game of war. So who's going to win in this case? The 1 or the 1/4? The 1. So what do you get?
3/4.
Good. See how it's a mixture of what we've been working on? It's not a lot of craziness involved here at all. What's different between what you've done the past few days versus this? They're starting with this as opposed with starting with that. They're making you write down the equations first instead of giving you the specific equation to simplify out or the monomial. Okay. That's the only difference between what we've done for the past few days and today. Kinda. This is a little bit. There's a little bit. Okay there. Yeah, this is like I said, this is bad. There's a little bit less intensity of some of the rules as what we were working on. I mean, here we have your two functions are 3x to the -1 and 2x minus 1. And when I'm going to do these composites together, basically what this is telling me is you take each of those values and you substitute an x into the other equation. So if I have 3x to the -1, and g of x is 2x minus 1, what is f of g of x? You start with the g of x equation, which is 2x minus 1. And that is going to be substituted in for the x value in the f equation. Well, the x value in the f equation is being raised to the -1 power. Do you agree?
Yeah.
So all I'm going to do is this. And that's your composite. I'm taking one and substituting it for the other. Okay. Taking one and substituting it for the other.
Can you solve that
You can simplify it down a little bit more since you've got that whole jump to the -1. I don't know if the directions will say leave all. It depends what the directions say. If the directions say make sure all your exponents are positive. If that's the case, then you rewrite it. How would you rewrite it then? Is it?
It'll be under 1.
Yeah.
But I don't know how you do
It'd be 3 over 2x minus 1. Okay. If it said make sure all variables are positive, which it might, I honestly don't remember if it says that or not. If it says that, then you just simplify it out with the exponent rule. Not that bad though, is it? I hope. All right. Same thing going the other way. If what is g of f of x? Write down the f of x equation. And then surround it with the g.
Oh.
What I'm doing there is that f of x equation is going to be the x part in the g of x equation. So you start by writing down what you're going to surround it with. Sometimes it's a little bit easier to do that. Now you're going to give me scrunchy face. I'm sorry.
So if you want to simplify that, you multiply it or like that first part by 2 and then you just subtract it. Wait, how do you?
If you're going to simplify this one, since it's just the x value that's raised to the -1 power, you wind up with 6 over x minus 1. That's it.
So it wouldn't be 6 minus 1 over x.
Because the -1 is tacked on after it, it's not built in with it. And that's all it would be if it said to write it in terms of positive exponents. And then the last one, what is f of x?
3.
So you start with the 3x to the negative 1, and you surround it with 3 to the negative 1.
So it would be a positive
Well, let's see here. Would that just be x?
2.
Or it could be 3.
Would it be? Would it be?
Moving on, actually.
Yeah, well,
What?
what does it add together?
Hold on. Think about your rules. Think about your rules.
Would it be 3 over 3x?
What are your rules? Your rules are to distribute that negative power to both of them, right?
Yeah.
So would that make it positive 1?
It would. What's 3 to the negative 1?
1 over 3.
What's 3 over 3?
3, 1. Wait, why is minus it?
What's negative 1 times negative 1? So that one would simplify out to be just.
Why don't... okay, never mind. I don't think
When I distribute my rules,
so. Oh, you have to distribute it.
yeah, because that's what we did the past 3 days.
I'm sorry.
Power to power rules. Power to power rules, you distribute out the exponents. Where did what go?
What's 3 times? I don't know what 3 times 1. That's 1. Okay, wait, sorry. Yeah, I'm still.
Okay. Let's see. These are. I want to do that after one. No. Try those real quick.
All of them?
Yeah. So building a little bit of this, we're running ahead of schedule here. What these things allow us to be able to do is the following: is that function notation allows you to solve what are called inverses. If you use function notation, f of g of x and g of f of x, that kind of thing, you can say that the two equations themselves, the two functions, can be inverses of one another if and only if the following thing happens. If you take an f of g of x equation, substitute together, and you get x, and you take a g of f of x equation, and you also get x, that means those two values are inverses of one another. Right? That means those two equations would be inverses of each other. Yes, ma'am?
Should I be writing this like a really slow?
Well, I'm going to do this part today, since we're working with inverses and stuff. Just the actual verifying part, when we do the find the inverse of an equation, we'll do that part tomorrow.
So, where are this?
So I'm mixing a little bit of this together. Let me give you an example of showing how you can see whether or not they are inverses. Folks, you can leave that up there. If I wanted to verify that two equations are inverses of one another, I would do the following. Excuse me. Say f of x I'm going to do that. And what I want to see is, are those two equations inverses of one another? If those two equations are inverses of one another, if I take one and I substitute into the other, simplify out and I get x, and I do the same thing with the other one and I get x, that means those two equations are inverses. Okay? So here's what happens. I'm going to check f of g of x, which means I write down the g of x equation, and then I surround it with the f equation. The g of x equation is 1/2 x plus 2, and I surround that with the f equation. So I have to multiply this part by 2 and subtract 4. Everybody okay with that?
Yeah.
So what's 2 times 1/2?
1,
What's 2 times 2?
4,
So I wind up with x plus 4 minus 4, which is?
x.
All right. First way of going that direction, I get an x value. I'm going to check the other direction.
What's your x value?
Nothing. I just simplified out to get x. That's all. I don't know what x is. I don't really care what x is. I'm not trying to solve for it. I'm just substituting back and forth. When I go the other way, take the g of f of x. I start by writing down the f of x equation, which is 2x minus 4. And then I surround it with the g of x equation, which is half plus 2. So, what's half of 2?
1,
What's half of 4?
2,
So I have
negative.
x minus 2 plus 2, which is x. That means, yes, sir?
If you got both equations to be 2x, would that be inverse 2, or is it just?
It has to be just x. It has to be just x. That's by rule. It has to simplify out to equal x. So what happens here is that means these two equations are inverses of one another. Okay? And the way that you can write an inverse, they write it to the negative 1 power. And you might have seen that before. Something to the negative 1 is an inverse. 3 to the negative 1 is the inverse of 3, 1 over 3.
Where is that supposed to be?
I'm just saying that they are inverses. We're checking to see if they're inverses by putting in one for another. Yes, yeah, they're inverses. That's just the notation that they write. That's all. It's not a big deal. It's just whether or not are they inverses. Let me give you another one.
Chocolate just disappeared.
Come on, guys. Are these inverses of one another?
Is there any like tricks to just like tell it off the bat?
Not really, unless you could graph them. Sometimes you can graph.
If they were grass, would they go in like opposite directions?
Not necessarily.
Never mind.
And we're going to talk. We'll talk more about finding the actual inverses of equations tomorrow. What I want to do today is work with the f of x, g of x notations. So I want you to check and see whether or not these two guys are inverses of one another. Remember, in order to check that, those two statements have to be true. If you substitute in one for the other, you have to get x both ways. Take a couple minutes, see if it works out. All right, take a look. When you start this, what you're going to do is you write down the g of x equation. Guys, come on. I really can't talk over people. You write down the g of x equation, and then you surround it, because this is now being substituted in for x here. You surround it with the f of x equation. Put a 3 out front. This has to get cubed. You add 1. Cube root of something cubed is 1. So my exponents go away. Do you agree?
And then you boil the.
So this happens. You okay with that?
Yeah.
What's 3 over 3? 1. So you have x minus 1 plus 1. See how that worked? By the heart. And I told you, you'd be surprised at how simple it was if you wrote it out. Does that make a little bit more sense?
Now I need to have it.
And, yeah. Yes, ma'am. Which 3s? The up front? Because this is 3 times this over 3. So it's 3 divided by 3. You can do that because it's multiplying straight through. Each one of those is its own term. X minus 1 is a term. Okay. Now, we wind up with x here, so we check the other one. We start with the f of x equation, which is 3x cubed plus 1. And I'm going to surround that with the minus 1 divided by 3 all to the third power. I'm sorry, excuse me. There's nothing inside this parenthesis that I can do it all to simplify. Do you agree? So what's 1 minus 1?
0.
0. So that goes away. What's 3 divided by 3?
3. 0. 1.
Which is it?
1. It's 1, not 3.
Cube root of something cubed is?
X.
Are they inverses?
Pretty fancy.
Was that you, Chloe? Yeah.
And you get inverses then.
Yes.
To be honest with you, the actual work of this is not complicated. What happens is that you guys will write something incorrect as you're writing it down. Izzy?
So why do you have to put the parentheses inside of the
Yeah, that's the
parentheses? Just take them away.
I can't hear her. Can you please stop talking? I'm sorry, Izzy.
Like, I mean, you wrote the original equation and you wrote it back in,
Yeah.
you put like 3x to the third plus 1 in parentheses and like -1, but you just take them away.
Because there's something inside the parentheses that I had to do. It's habit for me to do that because if you look back at when we put g of x into the f of x, I had to cube it right away. So it's just habit for me to put things in parentheses. You'll notice if you can do anything or not, you can just disregard them if there's something you can do. Okay, that's all it is. It's just habit. That's all. Okay, that's all it is. All right. Do one more.
I got one.
Bless you. Check and see if these guys are inverses. See why I put that one in parentheses?
Yeah.
The reason I put that one in parentheses is because the g of x equation has to be to the 5th power. So the 5th root of jump to the 5th is jump. So you wind up with 7x minus 2 plus 2 all over 7. You get x, yeah. This simplifies to 0, these drop out, you get x. We okay with that? Go the other direction. G of f of x. So we have x to the 5th plus 2 over 7. Surround that by 7 minus 2 and take the 5th root. Well, simplifying order of ops here, 7's drop, don't they?
Yeah.
Okay.
And then the 2's are gone.
The 2's drop, 2 minus 2 is, that drops. So the 5th root of something to the 5th is?
X.
Or jumps. Are they inverses?
Yeah.
Yes.
We can do a couple of these between, this is 7-3 and 7-4. We're going to do a couple of them both in there. Yes, ma'am?
Are we gonna have ones that aren't inverses?
Yeah, we'll get there. Yes, ma'am?
Will there be some where one of them equals X but not the other one?
Because that means they're not inverses then.
Well, yeah, but will we have some like that?
Oh, you might.
I haven't known they do that. Didn't the last one? Oh my gosh, next week they do That's a good run. This one's done. You're like the run's over.
There's a couple of, it's all straight function notation stuff. That 7-3 is the rules, adding the two functions together, subtracting, multiplying, dividing, things like that. The second part, that 7-4, are like the examples we just did about verifying to see whether or not they are inverses. There is a little bit, there's a part on number 30 and 32 where they're talking about where x has to be greater than or equal to 0 because the function that they're working with is an even power function, so we're just looking at positive values, not doing plus and minus. We'll talk a little bit more about why that occurs tomorrow. We get into more of our inverse stuff. I just thought it was an easy way to introduce something. Are you down to your last couple of sheets?
I'm on my last sheet right here.
Big one that won't last until after finals and
I'm so close. I have only
Yeah, that's my last right here.
All right, give those a shot. You should be pleasantly surprised.